Math Blast 23. I can add and subtract multi-digit numbers. Find the sum of 193,281 and 247,425. So the sum is the answer to an addition problem. I'm going to add my two numbers. Notice how I'm going to line up my place values here. So I can add like units. In the ones column, I have 6. 10 tens will make a larger unit. 7 hundreds. 10 thousands will make a larger unit. 14 10,000s, we'll take 10 of those 10,000s and make a larger unit there. And 4 in the 100,000s. And so the sum, the answer to the addition problem, is 440,706. Find the difference between 651,027 and 135,629. Now the difference is the answer to a subtraction problem. So here, I'm going to subtract my two numbers. And again, notice how I'm lining up my place values. All right, I start with 7 ones and I need to take 9 ones away. So I'm going to go over to my tens and I'm going to rename one of those tens into 10 ones with the 7 that's there. And that's why that becomes 17 ones. Minus 9 ones leaves us 8 ones. I have 1 in the tens and I want to subtract 2. So I'm going to go over and rename some hundreds, but there's none there. So I'll have to go over to my thousands. I'll rename the 1,000 into 10 hundreds. And now I can take one of those hundreds, leaving us 9 hundreds there, rename it into 10 tens with the 1 that's there. And that's why that becomes 11 in the tens. Minus 2 tens leaves us 9 tens. 9 hundreds minus 6 hundreds leaves us 3 hundreds. I have no thousands. I'm going to go over to my 10,000s, get one of those, leaving us 4 in the 10,000s. And the one I'm taking, I'm going to decompose into 10 thousands. So 10 thousands minus 5 thousands leaves us 5 thousands. I have 4 in the 10 thousands minus 3 10 thousands leaves us 1 10,000. And then we wrap it up in the 100,000s column, starting with 600,000s, taking one of those 100,000s away, leaving us 5 in that 100,000s column. So the difference, the answer to the subtraction problem, is 515,398. I can understand decimal fractions. Write each fraction in decimal notation and each decimal in fraction notation. Then locate each number on the number line. So 2/10 as a decimal would be written as 2 in the tenths place, 0.2. 4/10 would be 0.4. And 0.1 is a decimal, so we need to rewrite that as a fraction. That would be 1/10, 1/10. Now I'm going to locate each one of those on the number line. I'll start with 0 and go out to 1. That represents my whole. Since the units are tenths, I'm going to break the whole into 10 equal parts. And now I want to represent 2/10 here as a fraction. There we are. And I want to represent 4/10 here. And as a fraction, we can put that here. And then 1/10 is going to be back here, the first mark to the right of the 0. Now, what I want you to make sure is that whenever you're representing both forms on the number line, that you're putting those above or below each other and not beside each other, because 1/10 as a fraction is the same location as 0.1, 1/10 as a decimal, okay? So they need to be in the same line there. Crystal says the following number sentence is true. Julie says it is false. Who is correct and why? So 1/10 is less than 4/10. Well, if I were to rewrite my 1/10 as a fraction, it would look like this, 1/10. And I know that if I were to rewrite 4/10 as a decimal, it would look like this, 0.4. So now I'm going to use my fractions to compare here with an illustration. So if I have a tape diagram, I could break that into 10 equal parts. Notice that it is just like what we were doing with the number line above. And so this would be 1/10. In that same tape diagram, I'm just going to make a copy of that. 4/10 would look like this. And so 4/10 is greater, 1/10 is less. And so since the statement says 1/10 is less than 4/10 and Crystal said it's true, then we will say Crystal is correct. "1/10 is less than 4/10. And one way we know that is that 1/10 is to the left of 4/10 on a number line. And left is less. Okay, we're going to the back side. I can determine the perimeter and area of a rectangle. Determine the perimeter and area of the rectangle below. Starting with the perimeter, notice the key word in here, rim. I'm going to work my way around the rim of the figure. I'm trying to find the total distance around the figure. Opposite sides on rectangles are equal, so this side would be 3 centimeters and this side would be 5 centimeters. So the perimeter is going to be 3 plus 5 plus 3 plus 5, which we know is equal to 16, and all of those units are centimeters. So 16 centimeters is the perimeter. The area is the two-dimensional surface, and it's what we're looking at when we're finding area is how much space covers that two-dimensional surface. What are the square units that cover the two-dimensional figure here? And so we could actually draw that out. It's 3, if this side's 3, then it would be like 3 rows. And if this side's 5, then it would be like 5 columns. And back in 3rd grade, we first learned area by counting the square units within the figure there. And so we know that we would have 15 squares there. We then moved on to know that area is also found by taking the length times the width. So we could say, oh, well, that's 5 centimeters times 3 centimeters, or 3 centimeters times 5 centimeters. And that is equal to 15 square centimeters. I can determine the measurement of missing angles. Determine the measure of angle ABD. Well, angle ABC, this whole angle here, I see measures a right angle, 90 degrees. If angle DBC is already 60 of that, then angle ABD here is what's left. This is what we're trying to figure out. So angle ABD is going to be 90 degrees minus 60 degrees, which we know is 30 degrees. Angle ABD measures 30 degrees. I can identify and construct parallel and perpendicular lines. I can identify quadrilaterals. Look at the figure below and identify one set of parallel line segments. Then classify the figure. So here, if I see AT and OG as being parallel, that's my one set of parallel lines that I can identify. How do you know the line segments are parallel to each other? So I'm going to say AT is parallel, line segment AT is parallel to line segment OG. And I know those are parallel because they will never touch. They will never intersect each other or touch. They are equidistant apart. All points on those lines are equidistant apart at any given space. So here and here, this spot and this spot, like those are all going to be equal distance from each other if we were to measure them. Circle all that apply. We have a quadrilateral, it's 4 sides. It's a trapezoid because it has at least one pair of parallel sides. It is a parallelogram because we've identified one pair of parallel sides, but guess what? Here's another pair of parallel sides. A rectangle has 4 right angles, so it is not a rectangle. A rhombus would have 4 equal sides, so in this case, we would have to really kind of measure and look there to see if that AT and TG were to equal the same length. And so as I measure off here, I can see, nope, those are not of the same measurement, so it's not going to be a rhombus, and it's not a square either, because a square has to be a rectangle and a rhombus. A square has 4 right angles and 4 equal sides. So we have a quadrilateral, a trapezoid, and a parallelogram, with the most specific name for our figure being the parallelogram. That's all for today.